My name is Walter Latimer, and today we're going to be talking about duck typing. So, duck typing is an important concept in a lot of modern web languages, such as Python, Ruby, and JavaScript. Many people think they understand what duck typing is, but there are a lot of common misconceptions about it. So, at the end of this lesson, we'll be able to answer not what is duck typing, but rather, what can duck typing do? While duck typing appears in many languages, we're going to be using Ruby for this lesson. To get the most out of this, we're going to assume that you have a basic understanding of Ruby syntax. If you can define a class, you should be fine. If you need to get caught up, you can check out Codecademy.com's Ruby track to get you up to speed. Where does the term duck typing come from? Well, the term's attributed to the author of Little Orphan Annie, James Whitcomb Riley. And the quote goes, "When I see a bird that walks like a duck, and swims like a duck, and quacks like a duck, I call that bird a duck." It doesn't actually matter in this scenario if the bird in question is a duck or not. All that matters is that we can predict that this bird's behavior will act like a duck. How does this tie into programming languages, though? Let's take a look at a method that we're going to create called yell. Yell will accept an argument, and what we'll do is we'll convert that argument to a string, if it isn't already one, upcase it, and add a bunch of exclamation points. So if we call yell on the string Walter, we should get Walter. If we call yell on the integer 3, we should get 3. And if we call yell on an array 1, 4, 5, we'll get that array returned in this yell format. So while this may not be necessarily the most practical method, we can see that it's not throwing errors in any of these situations. This is unique to duck-type languages. In languages such as Java, which are not duck-type, we would have had to declare the data type that we want passed in as an argument for each one of these methods. So we would have to write a yell method for string, a yell method for array, and a yell method for integer. We can kind of start to see where this is going to get cumbersome very quickly. So duck typing in this sense helps speed up the development process and makes developers a lot happier. Let's take a look at another example to see where this can benefit you when working on a larger scale application. For this example, we're going to have a music venue, and this music venue can put on a show. So we see here that we've already created a class for music venue with the method of start show. This start show accepts an argument called act, and by default we want this act to call its sing method. So we are creating an implicit contract here between our music venue and our act. Our music venue here is making an assumption about our act and saying that this act should be able to sing. Let's create a class called singer with a method sing to complete this contract. So, create a class called singer, and inside of the singer class we will have a method def sing. And sing will simply just puts out la 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 la. So now if we create an instance of our music venue, which we'll call Carnegie Hall, and an instance of our singer, which we can call Ariana Grande, if we now say Carnegie Hall, start show, Ariana Grande, we can expect the result here will be la 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 la. So let's test this out in our terminal. Perfect. Now, we know that singers aren't the only people who perform at Carnegie Hall. Maybe we've got a band or a group of singers. Let's create a scenario where we can allow this to happen. So let's define a new class, and we'll call this class our band. And this band should also have a sing method to complete this implicit contract. So we'll say that sing for a band puts la 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 with harmonies. Great. So now if we create a new instance of our band, and we can call this, let's call this TLC. So if we say TLC equals band.new, and we now say Carnegie Hall start show for TLC, we can expect this result to be la 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 with harmonies. Perfect. So far this works out really nicely. When starting a show works for anything that needs to sing. But what happens when the venue decides that they want to have other types of performers, like say a comedian? So let's create this scenario. We'll define a new class called comedian. And this comedian, instead of having a sing method, this comedian's probably going to have a method like tell jokes. So we can say tell jokes, and we'll just put knock knock for this one. Let's create a new instance of our comedian, and we'll call this Joan Rivers. Now, if we try to call Carnegie Hall start show on Joan Rivers, in English, we know that we should expect this to work. We know that Joan Rivers should be able to perform at Carnegie Hall, but our code doesn't know this. And when we try to run this, we're going to get an error. We're getting undefined method sing. And that's because our start show method inside of our music venue is expecting an act that can sing. We can revisit our music venue start show method. And we can add some conditional logic here. Let's say if the act is a comedian, then let's have this act tell jokes. Otherwise, we can have this act sing. And if we go back and run this in our code, we'll see that no errors happen. There's a problem here. And the problem is that we're explicitly telling the start show method what to do in the case of a comedian. But this isn't very extensible in the scenario that we have another type of object in the future that also tells jokes. Let's define a new class here called YouTuber. And this YouTuber might actually tell jokes as well as part of their act. And we also want this YouTuber to just puts out knock, knock. If we create a new instance of our YouTuber, Walter, and try to start a show at Carnegie Hall with Walter, we expect it to be able to tell jokes. We know that our start show method can accommodate for somebody who tells jokes. But if we run this method, you'll see that we're getting undefined method sing for a YouTuber. If we look at our music venue here, we can see that we're not making proper use of duck typing here. By explicitly saying, if this act is a comedian, we're excluding the possibility of any other objects existing that can have the same behavior as a comedian. If it swims like a duck and quacks like a duck, let's call it a duck. So instead of explicitly saying, if it's a comedian, let it tell jokes, let's try if the act responds to tell jokes. What this allows us to do now is to take a look at our objects based on their behavior and not what they actually are. So now our YouTuber, because it responds to telling jokes, we'll see that this now passes. We can now start to see the benefits of duck typing here and how this can make our applications more flexible and more future-proof. While duck typing can be extremely useful, there are a couple things that we're going to need to watch out for. As we saw in the last example, it can be a little bit difficult to start keeping track of all of our objects and knowing which responds to what. So we're going to need to pay extra special attention to not have any errors in our code. Those errors can sneak by in ways that they wouldn't be able to sneak by in a language like Java that makes you declare exactly which types of objects a method will accept. This can be a bit of a non-issue, assuming that we have good test coverage, but we can't always assume that we're going to be writing tests for 100% of our code. Now, another thing that we're going to have to watch out for is code that has unexpected behavior. We might have two objects that respond to the same method, but that method does two different things. To demonstrate, I've loaded up some code in IRB, and I'll show you. We're cleaning up the house, and we've decided that we need to draw the drapes. So we've got Sean, who is just a person, and if we tell Sean to draw the drapes, we can see that the drapes are now closed. But what happens when we're working with another data type? In this case, an Amelia Bedelia, a data type that takes everything just a little bit too literally. So if we tell Amelia to draw the drapes, she quite literally draws the drapes. This behavior might not be helpful and in fact may cause errors when we're trying to write our code in the future. So these are just a few of the things that we're going to need to watch out for when we're working with a duck-typed language. It's important to remember that duck typing isn't a formal type system like, say, static typing or dynamic typing, but rather it describes a certain type of behavior and a way of thinking about programming. And the sooner we can start treating languages that are duck-typed in a duck-typed way, the sooner we'll be able to build applications that are more robust and more flexible in a shorter amount of time. Thank you. My name is Walter Latimer. Goodbye. So this was a really fun process for me. This is my first time I've ever done some sort of video lesson like this, and it's so different from doing a lesson in front of a live class of students. There I can kind of gauge the temperature of the room with eye contact and stuff. This is very different. It's a little unsettling at first, so I learned a lot doing this, so thank you for this challenge, and I hope you enjoyed this as much as I enjoyed making this.